And ta-da, we are back.
Welcome back, everybody.
Hey, thank you for coming back with me, Amanda, here. I want to thank everybody for coming back because it's really a nice, still, and yet chilly night at the John Zach Memorial Observatory in picturesque northwestern Connecticut. But I will say this, it's sort of worth the wait because I'm pretty sure that the views of the nebulae that we've been looking at are going to actually just be enhanced even more. So we'll be checking that out very soon here. I have to reopen the dome, and that's not a big deal, but it is a thing I had to do. So I'm just going to have to go back here. Let me go back to my previous stuff. Get to my playlists. And let's play something.
Rocket Man's asking if anyone's going to watch the Delta II launch at 4 a.m. Can you launch things into space during a meteor shower?
Actually, that's a very good question that people don't often ask. I'm glad that Rocket Man thought to ask that question. Thanks, Rocket Man. Sorry we couldn't have you on tonight. We were actually just, talking about that earlier. I know you wanted to come on, but unfortunately, with the schedule and the chilliness and cold, my mind is very preoccupied with staying warm and just getting to the next object so I can actually work through it. So I hope that is acceptable to you. I think you'll come back. Because we like having you around. All right, so yeah, you can launch during a meteor shower. It's actually not dangerous anymore. So typically, than launching when you're not in a meteor shower, because the fact is, the meteors will actually many times the meteors will actually just be so small and so far apart and so distant from each other and distant from any rocket that you have an equal chance of being hit by a meteor that's just randomly coming into the atmosphere, which they do all the time. So you have a chance of that anyway. And in this particular case, you don't have that to worry about because this is just when you launch, and you try to have safe windows. That's true. And a safe window. I'm sorry, I'm opening the dome. I apologize for the the noise and my little bit of being sidetrackedness here.
I am seeing your YouTube page on Skype.
Yeah, it's because I haven't done anything yet.
Oh. Okay.
So you're right. You are, and I'm gonna get rid of it right now. But there. Now you're seeing the actual stream, correct?
Yeah. Good. No, I was on the YouTube page and I just popped out the chat and I went over to the stream and I'm like, wait, they weren't saying, because I could see the chat twice, but you can't see it on YouTube.
Yeah, that's right.
If that makes sense. Yeah.
All right, let's power up this beastie over here, and let's get us into the Wi-Fi mode here. There's a big truck going up the road. Sorry about that. Not my fault, Not my fault. What can I say? Alright, so no. Let us go to the Orion Nebula once again. Yeah. Actually, before we go to the Orion Nebula, let's do the Crab Nebula one more time. What do you say to that? Because the Crab Nebula is actually quite higher now. It's a lot higher, so it might look quite nice. I would really like to do that. And it's my stream, so I'm gonna no. If you guys have any objects you'd like to see, let me know, and we'll be happy to go off and check those out. I'll send Amanda first, and then I'll do it. I'm just kidding. Let's see here. Okay, here we go. Now, let's move here. There it is. Ta-da-da. Okay, and now let's move our chili butts over to this. Oh yeah, that's significantly higher in the air in the sky right now. So we'll see what we got. Okay. And now I have to do an acquisition frame, which you guys know means that I have to go into 4K video mode and see if I can catch it. I believe I have. So, let's go over here. Oh, that's the wrong thing. I had it on. Sorry about that. Get some nice starry trails. Okay. There it is. So now I can go over there and it won't be racing away. Okay, one more notch of movement. There we go. Okay. You probably don't notice this, but I do. When you look at this is on the 4K video mode. When you look at the Crab Nebula here, you can actually see the Crab Nebula at this mode. And earlier it was very, very hard to see, but now it's actually standing out. So let's go out and let's see how this supernova remnant looks when we take we'll do a 30-second shot at a speed of, I'm gonna say a speed of 12,800. Okay, 30 seconds at 12,800. That might be a little high, but we're gonna check it out anyway and see what we get.
Question. It may not be in the northern hemisphere, but where's the jellyfish nebula?
Actually, jellyfish is in the northern hemisphere. In fact, I actually looked to see if we could look at the jellyfish earlier in the month, and we can. I just have to see where it is located right now, and then I'll know. I can't remember exactly what right ascension and declination. That's the same as latitude and longitude, but to astronomers. And it's the celestial coordinate system as opposed to the Earth coordinate system. If you move longitude lines, which are the ones that go north to south on the Earth, if you move them out into space from the Earth, they are called right ascension lines. And they're measured in hours, and there are 24 hours of right ascension. And each hour represents 15 degrees of sky. 15 degrees. And that is something. I'm looking at the crab here and looking at it. Yeah, look at it. I mean, it looks so much better. You can actually see the filamentary structure very, very nicely of the crab. This is beautiful. Wow. This is the first time I've ever seen the filamentary structure so clear in this telescope. I've never actually had it on this before like this. This is gorgeous. Really, really pretty. So what do? I take it away from you. I'm going to do a couple more shots like this at 30 seconds. Now, I think it's important to talk a little bit about the Crab Nebula and talk about it. We did mention how supernovae occur, and we did mention that the star that made this supernova was above the Chandrasekhar limit of 1.44 solar masses. If you recall, that was the lowest mass at which or the highest mass, I should say, at which a white dwarf could be stabilized or stable. Meaning that if the star is of that mass or just below that mass and lower, then the star could be a white dwarf. If it's a higher mass than that, then the force of its own gravity can compress it past the forces that stabilize a white dwarf. And that could bring it down to neutron star territory. And usually if the star is that massive, then it's become a supernova. And so you see the supernova remnant, like we see here. And briefly, I'll do one more. Go ahead.
Okay, but the mass doesn't necessarily mean the size. It just means how heavy it is, kinda? Not heavy, but dense?
Yes, it has to do with how much material is there, how many kilograms of mass are inside of the object. And mass translates to gravity. So the higher the mass, the higher the gravity. That's why when we say something like, you know, a teaspoonful of neutron star matter would weigh well over 1 billion tons or two, we're actually taking a concept like mass, and we're kind of confusing it with weight. Weight is not mass. A mass will have or translate to a certain weight. For instance, you have a certain mass. That's an intrinsic value. That means it's a value that will never change no matter where you are in the universe. You're always going to be whatever mass you're at. Let's suppose you're 1,000, you know, let's suppose you're, say, 100 kilograms. Okay, let's suppose 100 kilograms is the number, all right? And I'll do this while I'm taking these pictures. And 100 kilograms is the same on the moon as it is on Pluto, as it is on the sun, as it is on Earth. However, because the mass times the acceleration due to gravity, which is labeled little g, so it's a g, on the Earth, that number is minus 9.8 meters per second squared. That's the acceleration due to gravity. Because the acceleration due to gravity is very important in figuring out the weight of something, it depends on the mass of a planet and its acceleration due to gravity. So if you figure out a planet's acceleration due to gravity, that is its gravitational force, then you can simply say, well, the acceleration due to gravity is minus 12 meters per second squared on this big planet out here, for instance, that we're looking at. And then that will be something that we can use to calculate the weight. Okay, because the mass of 1,000 kilograms times the 12, okay, will basically give us the weight on that particular planet. The mass times that acceleration due to gravity. All right, so that's how that works. All right, you know, that's the mg basically, and our weight is one that basically doesn't. I mean, it's a little more complicated than that, but the bottom line is that mass is an intrinsic value. It's a value that never changes, all right, where you are, okay? You don't have less mass on Mars and more mass on Jupiter, okay, or less mass on Jupiter. You have the same mass, but combined with the acceleration due to gravity, that can produce your weight. Okay, that's why on Earth we can say a teaspoonful of that volume of material can weigh 2 billion tons or so. All right, so that's how that works. So there's a little, you know, it can be confusing trying to figure out the difference between mass and weight. But there you go. That's sort of one is just a value that never changes, which is the mass, and the other is a value that's a combination of the acceleration due to gravity on a planet, that is the force of gravity from a planet, and your mass. So you see, one's a calculated value, one's an intrinsic value. It's that simple, if you want to think of it that way. So, in any case, I'm just liking the Crab Nebula. I mean, the Crab Nebula is kind of just, if you want to know where the crab is, it's actually just above Orion. Oh, hey, wait, what is that I'm looking at? Oh, I have an errant cloud coming through. How about that? Okay, we are gonna cut short the Crab Nebula, and we're gonna go right to Orion so I can get the views of Orion before any errant clouds come in and start to add any difficult seeing to our mix here. Alright, so now...
Either that or because you're still freezing.
No, actually...
People wanted to know if you warmed up, but you're still a little chilly.
Yeah, I didn't quite... Yeah, it takes a long time to actually warm up,
I know.
Unfortunately. Okay, let me go out of here. Let's go up to Orion very quickly. There we go. Alright. See, the thing is, you know, I can never move my telescope by hand because it's all computerized, and so I've got to be very careful about that. So I got to use the system to do everything, which is okay. Okay, here we go.
Rocket Man wants to know, anyone, do you know what's going on with the F9 launch and Zuma? Daryl said SpaceX said something about reevaluating the fairing on the craft and would announce a new launch date, but I don't even know what that is. An F9 launch and Zuma. Something to do with Elon Musk, maybe?
Yeah, I don't know what that is either, what Zuma is. Sounds like an exercise program. Oh wait, that's Zumba. Sorry. That's a joke. Very bad joke. I don't know. I don't know what that is. But since Rocket Man is Rocket Man, I'm sure he could tell us. So why don't you get him to tell us? Alright, now, you might remember the images of the Orion Nebula we took earlier. They were actually very pretty, but they are also kind of fuzzy and bad, okay? Now, speaking of fuzzy and bad, I just have to make sure. What's the matter?
I don't know, you were gonna say, speaking of fuzzy and bad. I just thought, oh, this can't end well.
Oh.
Unless one of your puppies joined you. That would be nice.
No.
No, they're too smart to be in the cold.
Yeah, they really are, although they like to go out. Okay, this is a close-up of the center of the Orion Nebula. This is what powers the Orion Nebula. Okay, it's the trapezium. These four very, very, very hot, young, and bright stars. And they have a lot of ultraviolet radiation that they give off. And this ultraviolet radiation will actually cause the hydrogen gas and oxygen and other gases in this nebula to glow. And they do that because, as I mentioned before, I started to anyway, the oxygen will actually be be ionized. That is, its electrons, one of its electrons or more will leave the atom and become a free electron for a period of time and then recombine with the atom later. But when it comes back in, it's dropping energy to come back into an orbit. It's called an orbital in the atom. And when it does that, it gives off light, and that light is a very characteristic color. Okay, for whichever atomic transition we're looking at. So this will be 8 seconds at 12,800. It's probably going to be very bright. I mean, for the nebula. But let's take a look at what we got. And this is mostly a H2, that is H Roman numeral 2 region. So here we go. And look at the difference. Okay, check this out. Okay, this is what we have now. Okay, this is just what happens when, okay, we are now with the Orion Nebula higher in the sky. Okay, compare that, what we see here. All right, compare. This is beautiful. Wow. Compare what we see.
Gorgeous.
Compare what we see here to this. Let me go past all the crabs. I've got
Gross.
crabs. To that.
Well, that one's still beautiful too. It's nice and dark. Like I do like the dark purples and dark reds, but
Okay. But
yes,
that
scroll
amazing?
back too.
Yeah, and now if we go back to the other one.
Watch your eyes, guys. Oh.
Okay.
Yeah, that's pretty gorgeous.
Right, and now if we zoom in on this now. Sorry, let me just go back to that for a sec. Okay, so if we zoom a little bit on this now. Okay, check out the little dark nebulae right there that you can see. Those dark nebulae are actually, they're more than just dark nebulae, they're actually called molecular clouds. And they're clouds of perhaps diatomic hydrogen, that's, H2, okay? That is H numeral 2, not Roman numeral 2, they're two different things, right? H2 is two atoms of hydrogen that are bonded together, perhaps, or some other materials. And there's also dust in here as well. Dust is left over. Dust is a very prevalent material in the interstellar medium here and there, and we've found a lot more of it. Now I'm going to just do one thing because this is, it's bothering me that we're seeing some grain, that is graininess. So I'm going to go to an ASA of only 4,000. I'm at 12,800 now, and I'm going to 4,000. And let's go to a 13-second exposure of the Orion Nebula. With a telescope like this, where it's aligned so well that it guides all by itself pretty much, I can actually view these things, and then it's hands off. I can just sit back and let it, guide and watch what it comes up with. Yeah, I'm getting clouds now. Crap. They'll move. They'll move. Look at this. Oh wow. This is the thing that it looks like it comes right out of a book, doesn't it? The Orion Nebula. This looks like it comes right out of a book. And
it looks like, I don't know. It almost has like not a three-dimensional effect, but it's like the black would be like if it was a painting, like the canvas, like it looks like it's layered, like layers of paint that kind of sit on top of each other, but not really three-dimensional, like coming off the screen. You know what I mean?
That is such a very, very I call it prescient, which means that you recognize something that is very important, but maybe don't even realize how important. That's a very prescient observation, because that's exactly what we're seeing here. The black is in front of us, is between us and the nebula behind it. That's dark molecular cloud that is superimposed over the bright nebula behind it. That is three-dimensional, all right, in that regard. So if you saw it in space, you'd be going through that material to get to the bright nebula behind it. Isn't that incredible? So you're absolutely right. You're absolutely right. Now, I'm going to come back to this, but I do want to go to one other. I want to try one other thing here. Let's go. I want to move up a little bit northward. I want to go to. Where am I? Is that what I want? Yeah, we'll do that. Okay, let's try this. I'm going to go here now. I'm going to move a little bit. I'll be back. You'll see. I'll be back. I promise. Oh, come on. There we go. I know my fingers are cold, but, you still can take my input. More input! Who knows the movie from which that was from?
I do.
Don't say it. You're not allowed.
Well, that's a pretty one-sided game, isn't it? Go ahead, chat.
Yeah, get a chat. Get a chat.
What line was... No, hold on. What movie was that line from?
More input. I'm not going to say more because then that'll actually give it away. There's more that is said that could give that away.
That's pretty clever.
Okay, now let's just do...
That's actually a really good impression, too. And I think a lot of people, even if they can't place where they know it from...
they'll know the voice.
Yeah, exactly. It's going to be one of those things like...
Well, I can add one little piece to it.
I can't place it.
I can add one little piece to it. Pretty Stephanie!
Okay, that's obscure.
That
I would not have remembered the girl's name was Stephanie.
Well, you didn't watch the movie as much as I did.
Apparently not. I watched it quite often, actually.
Wow. Okay, I want you guys to see this. This is the Flame Nebula, which is right near the star Alnitak in Orion, and it's just stunning. I'm just going to pop back for a minute, and I'm just going to move over a little bit and get us more close. Alright.
And a few people did know it. Jello knew it. Tracy knew it.
Okay. Fair enough.
Ray just thought you were maybe quoting Psycho.
Uh-oh.
I think that was just a joke, though.
Mom doesn't like this.
Daryl says he's getting buffering.
Nonsense. No buffering allowed.
Analysis.
Only if you're taking aspirin and it's buffering aspirin. That's pretty. I'm going to do another longer exposure, but check that out. That's the Flame Nebula. And that's Alnitak, the left-hand star in the belt of Orion, the leftmost. And the flame is really pretty. Man, that's really pretty. Gosh, I love that. That's gorgeous. And that's only, by the way, that's actually, believe it or not, that exposure is just 13 seconds. And I'm gonna drop the ASA to 20,000 and go up though to 20 seconds. Alright, so now we're gonna actually get a finer grained image with a longer exposure by one stop. Remember how f-stops work in a camera? Okay, they're, you know, the aperture is the opening in the camera, and when you're working in a telescope, you know, that aperture is pretty much the same. Mine is 10 inches in diameter. Okay, and the telescope has a f ratio, all right, and that f ratio, if it's a low number, it means it's a faster optical system, so it can capture more light quicker. This is a faster optical system. It's an f6.3. All right. Oh, that's beautiful. A few more of those, please. Yes, sir. Right away. And when we look at objects like this, which are the Flame Nebula, when we look at objects like this, we're seeing another nebula that is actually illuminating because of a hydrogen ionization process, the same way we talked before. H, Roman numeral 2, is what we're seeing here. And the H2 region is a very ubiquitous region. It's that we see them all throughout the universe. And as we saw in the Triangulum M33 galaxy, we saw them there as well. So now we're looking at this particular H2 region that's here in our galaxy. It's in Orion, and we're watching it. We're seeing it actually, and it's. Hang on, I'm just looking at that cloud. Go away. All right, it went away. They listen to me sometimes. So the truth is, when we look at objects like this, we don't know what kind of nebula they are unless we've done some research. And we know this one is an emission nebula that's illuminated because of a star nearby. And as I mentioned before, sometimes the stars that are doing the illumination are not visible to us because they're in a dark nebula that might be illuminated. And that might be hidden rather from us. And that happens a lot with stars that we look at in Orion, because Orion has a lot of dark molecular clouds in it. Because Orion, you know, is the other end of the Milky Way. It's the other end of the summer Milky Way. When you look at the summer Milky Way going through the sky, it goes all the way down and back through Orion. Okay, I mean, it goes all the way around the sky, 360 degrees in a loop, because it's all around us. We're within the disk of the galaxy, and we see it. But look at this. This is beautiful, huh? I'll do one more here, and that should be enough to give us some information with which I can stack later, and then send up some raw images for you to look at. So here we go.
And that would be on the Facebook compilation page.
That'd be on the companion page. That's
what I meant.
That's okay. To SkyTour LiveStream companion page on Facebook. Yep. And then of course I will post them on my Facebook site at Mark D'Antonio, and then I'll put them probably to Astro Imaging Live as well, which is our other site.
That connects all three. That connects this channel, P&K Space Imaging, NY Skywatcher.
That's right. That's right.
You gotta let them know there might be new people here.
That's true, you know, and I'm glad you do it when I don't. That's very
And
important.
you can also find Astro Imaging Live on Facebook as well.
Correct. That's absolutely right. Okay, we're going to move down a little bit. Just a tad. There we go. Not sure if we will be able to see what I'm looking for. Oh, maybe I will. I don't know. We'll see. Okay. So now, let's just do 20 seconds at 20,000 sensitivity, 20,000 ISO sensitivity here. And we will see whether we can see this.
We have a guest coming in.
Okay.
Are you looking for the horse head?
I am indeed.
Ah!
So we'll see if we can see it. Now, again, Orion isn't fully high in the sky, and the sky for seeing dark nebula needs to be pretty dark. But I'm not sure if we'll be able to see it. Again, I am having a medium sensitivity. I'm not even at a very high sensitivity. So it's possible. And there it is. Holy cow. All right. Well, I take it back. It was there. I'm just going to move us over a little bit to see this a little better. And just to show you what I was talking about. All right. Let's go back for just a minute. And there you see, amongst other nebulous detail that you can see on the star above center, just right of center, you can actually see a reddish cloud, and that reddish cloud backlights the Horsehead Nebula, which you can actually see there. That's pretty cool. Now, this is a first for this telescope. You're seeing it with me for the first time, and I'm telling you, I am really excited. This is so cool. I'm going to actually go to 25 seconds at 25,600 and see, because I've gone up 2 stops. I've gone up, I'm basically exposing it for a little longer, and I've also increased the sensitivity. And because they're related 1-to-1, by doing that, I end up seeing 2 photographic stops increase in my brightness to come. And that's just, man, this is something. And this isn't even all the way up in the air, up in the sky. We're still looking through a fairly significant what we call air mass. So, but this is very promising to me. I'm really liking this. I've never seen a horsehead from Connecticut, ever. Ever, ever, ever. So you're seeing it with me.
But Daryl said he's only seen this once, so I think everyone's going to be in for a treat here.
This is something else. I'm even going to move us up a little bit. Okay. All right. Wow, that's something else. I don't know how this will process out, but we're going to be trying it. I've actually been learning quite a bit of processing skills for Photoshop. In fact, I mean, there's certain techniques that you could use to get better pictures, sharper pictures, better looking imagery, less noise from higher sensitivities, and I've been experimenting with all of these to what I think would be at the point where anyone watching me would say, "You have no life, man." Because, but I think that by processing these and making them as pretty as they can be, I think what that does is that increases people's understanding and awareness, and then they see just how pretty and how beautiful the universe is. The universe right over their head that they never even look up and see. And there it is. I mean, there's the horse head right there. You can actually see it when I actually allow it here. It's crazy. Let me do this. All right, here we go. There we go. So now you see it there. Now, just imagine this view without all that graininess and without the blue. When this is darker and has higher contrast between that horse head itself and that red behind, it's going to really look much, much nicer. So much nicer. And this is stunning as it is. So for what I'm doing, for what we're doing, I should say, this is really something. So I'll do another one. I'll do 2 more like this, and then we're going to actually move on to other things in Orion. There's something else I want to show you. It is weird. There's a strange cloud that's actually forming. It's down in Canis Major, which is the constellation below Orion. Canis Major, the big dog, and Procyon was the little dog, which is it's the bright star kind of to the left of Orion, it's sort of if you go equally between the top and bottom of Orion, from between Betelgeuse and Rigel, okay, and then you go directly to the left. You'll see this out there. Okay, this is pretty. One more at 39% battery in this battery, and then we'll move on. I have to do a number at each exposure to get some that are perfectly good, I'm glad it came out again, guys.
We are too.
I want you to have an opportunity to explore Orion with me. There's something to the left of Orion in Monoceros, which is the unicorn. Okay, it's a unicorn, and the constellation, and it's a cluster of stars that has an associated nebulous cloud of star forming region, again H2 region, and it's called the Rosette Nebula. Now, it's not that bright. As you can see, the horse head's actually pretty faint. This looks kind of dim, as a matter of fact. Now, once I get an auto-guiding system on the telescope, which is not on here now, I have the telescope in the house for it. Once it's on here, and it's not going to go on probably till Arizona, it will actually be able to guide for very long periods of time while I'm using the super sensitive camera. So we'll be able to get far more stuff this way. It's going to be gorgeous. So that was the horse head. Now what I want to do is take us to. I mean, the flame was beautiful too. The Flame Nebula. I mean, where you just how many places to go? It's incredible. You don't stop. You don't have to stop. All right, I'm gonna head over now to the Rosette. And as you can tell, the telescope didn't move very far, did it? And that's because Monoceros is right nearby. Right nearby. Okay, and it's going to be fairly large in the view here. unfortunately. Okay. I don't know how well it's going to show, but you know, again, I've never seen the rosette ever, except in photos that have been taken elsewhere. Never seen them here. So let's do another. Let's do 25 seconds at 25,600. And I'm actually going to move us over because I know that it's associated with that cluster of stars. So let's see what we get. Ooh, I'm so anxious. I know this is sort of a quick run through Orion and its nearby fun things, but then we'll be back to the Orion Nebula before we end. I want to show you that one more time. The Pleiades, of course, is almost at the zenith, so that means that we would actually be able to get photos of the blue nebulous, a reflection nebula around that pretty well. But we may have to make that another night because my hand warmers have stopped working. Ooh. Let me show you this real quick here. The rosette is pretty big, okay? So when we're looking here inside this this cluster here of stars, okay, the rosette actually surrounds the cluster of stars, and it's massive. So we're only seeing a very little bit of the rosette right now. But just to kind of give you an idea of how much more there is, let's go this way a little bit, and then this way a little bit. Okay, and let's do this again. And and of course this isn't at the zenith at all, but it serves to show it. It serves us well to show it. So the Rosette Nebula, like I said, another star-forming region, H2, and the stars that formed in it, you can see right there in the center when we showed you the picture. And then you notice there was a dearth, that is an absence, of nebulous cloud near the stars. Well, there's a reason for that, and that's because the stars are young and energetic, and they're actually, with their strong stellar winds, they're actually dispersing the gas nearby, near them. And so overall, eventually, you're going to get a complete loss of this nebula entirely. You'll never see it again. All right? That's just how it works, So let's go. I don't want that. I want this. Okay, now, if you look, you can see the cluster here on the right, but on the left, you can actually see, and down here, you can actually see that there's more detail here. It looks like an arc, it arcs, around from the upper, right near the date where it says November 1718. It starts there, right around the 2017, and it arcs down a little bit to the left, and then down to the right more, and then there's more nebulous detail more toward the center as well. So it's a big thing. So this would actually be better served using telephoto on a camera that's mounted on the back of the telescope, piggyback mount. So seeing it like this is not the best way to see it. If we just wanted to examine the stars, then we do this. But to get past this and do something different, we would actually want to get out of the out of this. But now we're going to look at something else that I have been really anxious to see for a long time, because I photographed it in a 20-inch refractor when I was doing a parallax program study. This is a different object. It's in the same constellation, and it's not far away, and it's the coolest little thing in the world. So let's go take a look at it. I'm not telling you what it is.
Daryl wanted to see something, wanted to know can you detect the Cone Nebula or Hubble's Variable Nebula?
He's funny.
Or is that where you were going?
Yeah, we're on Hubble's Variable Nebula. That's where we are. Yep.
Oh.
Whoa! What the hell happened there? Stop. Uh-oh. I got a problem here. Stop, telescope.
Wow.
Yeah, we got a problem
Hi,
here.
NSA. What do you want to show us tonight?
Hang on. I have no idea what the... Hang on 1 minute. I don't know why the telescope is going crazy now.
Wow.
Oh, shit. Stop. Stop, stop, stop. I have no idea what it's doing. Okay, that's not good. Oh. Alright, I have no idea why the telescope is having a fit right now. So I'm going to have to disconnect the Wi-Fi entirely. I don't know what's going on here. I don't know what it thought it was doing. But everything was fine. All of a sudden, and it hit a stop and it screwed up its alignment, I'm sure. But yeah, it thinks it's lined up with something, and it didn't. So let me try something here. Darn it all! I wanted to go to this thing, and I'm not going to be able to now.
Why?
Well,
Because
because
your telescope went crazy?
yeah, I went crazy, and I can't trust it. I can't trust it. I mean, it spun all the way around, and it hit the hard stops, then has a dew cap on there, and then that dew cap ran into the base, and then it kept trying to go past it, so it got its alignment all screwed up. So I can probably tell you what I'll do. I'm going to manually move it. Not manually, but I'm going to use my hand control. I've never seen this before. This is a strange thing to happen all of a sudden out of nowhere to this thing. And that is a failure of some kind, and we're going to have to deal with that probably tomorrow, along with everything else that this observatory had to suffer lately. Okay, let me okay, get this cable uncabled. Okay, here we go. What's my speed? Let's see. Never say die. Okay, let me see here. Okay, that's not good. Let me do speed. High. Okay. Alright, and now I'm going to go down. Alright, let's see where we are. I have no idea what that was, so I don't know. But I am going to see if I can, at least before I have to realign, which will have to happen tomorrow sometime. I gotta see if I can do something here to help alleviate the problem. And it was it was good, and we got to see the Orion Nebula at least, and you know, some of these other features. Okay, so I got the Orion Nebula back, and what I'm going to do is, no, not that. Now, let's see. All right, we'll go there. All right, now let me try an emergency alignment procedure that may or may not work. just so you know. Let's see here. I'm here. And let me see to make sure I'm there. Let me grab that. All right, and okay, now we're here. All right, so now I say align. Okay. I did an emergency alignment, which I do not know if it will work. Alright, but I have to try this. So I'm going to try and send this to something that we know. Like, let's do something easy, like go back to the Flame Nebula. And let's see if it'll understand that. Alright, here we go. Okay, it's moving the right amount. And it looks like it did the right thing. Okay, seems like it did the right thing, but let's see if it did. Let me just do a quick shot, not a keeper, but let's just do a 10 seconds at 25,600. We should be able to see the Flame Nebula, and it should be right about the center of the view if it's worked. If it's worked, then we can carry on and do something else. There we go. Okay, so it worked. Now, let's return to where we were going before. Once again, I wanted... Why was he taking more pictures? It's like the camera's got a mind of its own. I don't know what's going on. Okay, it's still taking pictures. What are you doing? Oh, I must have told it to take a bracket. That's what must have been. Okay, hold on. Let me get us out of that. Oh yeah, I did. Duh. Okay. Now, let's go. And this whole thing has kind of left me a little thrown off here with everything else. Okay, let me pop us back out. I wanted to see, again, Hubble's Variable Nebula, which is exactly where I was going. And now I say go to one more time. It should not go nuts. Yeah, that's more like it. That's more like what it was supposed to be. Alright, and let's now look. Let's do a 10 seconds at 25,600 to see if it's in the view. Hey guys, thanks for bearing with me when I had the telescope run amok. I almost shut it off, which would have ended our night, and I sort of waited it out and to see if that was going to be a problem. Because, you know, for the stuff we're looking for, you can't just go pointing at, oh, right there in the center, look at that. Okay, this here is Hubble's Variable Nebula. Now, why is it called a Variable Nebula? Because it actually changes brightness depending on the star. The star that you see illuminating it is right there in the center, and that star, okay, is a variable star. So the nebula, Hubble's Variable Nebula, actually changes brightness depending on how the star changes its brightness. This is a very cool thing. And when I imaged this nebula when I was in the parallax program, I kind of absconded with the telescope for a while. It was like a 35 or 40 foot long telescope, 20-inch diameter lens, big refractor, and I focused on this nebula, and I took this picture that I took, and it was just outrageously fun, really good. All right, that was a 10-second shot. So let's go and now do a full 30 seconds at 25,600 to see what we get. My telescope is half the diameter of the refractor that I was using, but the refractor was a lot slower optically, meaning that it had a focal length, an F ratio actually, that was way up near like f19. Now this telescope has a focal ratio. It's a its f number is 6.3. The one on the refractor was 19. Now, remember what I said, the smaller the number, the brighter the image will be, and the shorter amount of time is required to capture something. So that's what we have here. We have something here that is going to be captured at f6.3. That is a faster optical system than the refractor that is twice as large that I used. So this will be the first time I've ever seen this in this telescope. Not counting the last moment I just looked at it. Wow, look at that. You can actually see such detail. What a beautiful sight this is. Alright, no, I'm doing this. See, I'm wearing gloves and trying to handle the telescope, and it's making it really hard to push certain buttons. And every time I pull out my...
They're more like big puffy mittens, and the finger flap comes down.
Yeah, that's the problem, and I can't... When the flap is out, I can't see where I'm looking or where I'm reaching. Yeah, see, that's pretty much the nebula right there. Now, I don't know the state of the star, so I don't know how bright this nebula is supposed to be right now. So I'm not sure if that's the right brightness, or if we're gonna be looking at a different brightness eventually, or brighter. But that's Hubble's Variable Nebula, and that's a very cool little very cool thing. Now, again, there's one more right near us here, not far away at all actually, that I would like to have us look at. And
Daryl says he read recently that some think dust clouds orbiting close to the star are casting their shadows against the larger clouds farther out. Did you hear anything about that?
Yes, as a matter of fact, that's true. That's a possibility, and that's something interesting about astronomy. Just when you think you have it all sewn up, then another theory comes along, possibly. Now this, let's do 25. Let's do an acquisition first. Let's just do 15 seconds at 25,600 to see if I'm going to see what we're looking at here. See if this is working.
Is that why it changes brightness in short time frames?
Well, it's changing brightness in the short time frame here because of the fact that the star is a variable star, and as it changes brightness, because the nebula is a reflection nebula, that's what we're seeing here. Okay, we're just seeing the reflection, and if the reflection is not as bright, or if the star is not as bright, then the reflection is going to be not as bright, and that's kind of what we're looking at. Okay, this is, it's sort of there, but not really there. This is the Cone Nebula. It's really not very obvious. I know that.
Oh, sorry. You know what? I thought it was because Daryl said something about the Cone Nebula in chat, and someone else brought it up, so I actually thought either maybe you said it or everyone already knew what it was.
Oh.
Yeah. A few people did know it was Cone Nebula. Wow, cool.
Yeah, they recognized the cluster. But I don't really see it too. It's not obvious right now. But there's this is just the acquisition type image. If I want to look at it, let's just do a full 30 seconds. And let's even go up to 32,000 ISO sensitivity and see what we get. There's also some clouds around, so they're kind of, barking at my camera probably, so I'm not pleased with that.
Ted wants to know, can a nebula cast a shadow at that kind of distance?
Well, a nebula can't cast any shadows. It's actually, the nebula is excited gas. A dark nebula, okay, let me be fair. Um, when I think of nebula, I think of emission nebula. Now, but emission nebulae are glowing, and technically they will send out light that could then reflect off of dust elsewhere. All right, and we see that actually quite a bit in astronomy. But as far as casting shadows, typically the stars are brighter, and stars will cast shadows more so than any nebulae will. So that's pretty much what we're dealing with there. I don't see the nebula. Yeah, and I see a hint of it in the little lower to the lower right there, but I do not. It has to be a darker sky. We need a little bit darker sky. So that is, however, that's the Christmas tree cluster. Just so you know, that's what that's called. And it's literally 2,200 light years away, so that's not close. Oh, come on, I'm starting to get cold again. I know. Alright, so we saw that. We saw Hubble's Variable Nebula. We saw a bit of the Rosette. And we just took that tour all the way around. And now we saw the...
Oh, what about the jellyfish?
Yeah, let me do a quick search and find out where that is. Don't forget now, I did a emergency alignment, and it's only good for a certain area of the sky.
Yeah.
But I'll see where it is and see if we can do it. I'm too cold to actually do a real alignment. I'll have to wait till the next clear night where I'm still warm and fresh, and I'll be able to do an alignment.
Would you like to hear a poem about a jellyfish? Say yes.
Yes, absolutely.
It would be spiteful to put a jellyfish in a trifle.
Trifle?
Yeah. Well, it was Carl Pilkington, and I enjoyed it.
No, it's okay. I just don't know what it means. Is it truffle or trifle? I mean,
A trifle.
What's a trifle?
I don't know. What is it?
Okay.
It would be spiteful.
Put a jellyfish in a trifle.
Yep.
That's funny. It's funny in a strange way.
It's a weird thing to have come up with, I thought.
Yeah, it's
And I like it.
Cute. You know, I mean, I can be weird. People can be weird. I am weird. After all, look at me. I can't believe I do this. But I love doing this. Okay. I'm going to be... part 2 of the SkyTour LiveStream is going to be a little shorter than the first. Because once you're cold, you stay cold. So what I'm going to do is I'm going to take us to our final object for the night, which we've all seen. But I just want to get the final view of it before, you know, as it's getting higher in the sky. And I want to be able to see it and see just how it looks, you know, in finality here. Alright, so let's take a look. And it's the Orion Nebula, yes. And see, it's right in the dead center because we aligned on it. So now I'm going to try something odd. I'm going to do something crazy. I'm actually going to, first of all, I'm going to take out my thumb, and I'm going to be able to move the wheel better. I'm going to do, at an ASA of 20,000, I'm actually going to do a 30-second exposure, which is crazy because this nebula requires so much less than that. But it might be cool to see what else we can see around the nebula. More details, in other words, that we can see. And I appreciate all of you who've come back to see this continuation of the SkyTour LiveStream. I appreciate that a lot. And by the way, I mentioned in part 1 that the observatory was severely damaged in the windstorm. The shutter on the telescope dome was actually ripped right off, and it's several pieces, and they slide down the track, and they have wheels that retain them and hold them to the building. And it was torn off, and there was big holes, big gaping holes ripped out of the plastic from where the shutter pieces were torn from the building. And luckily, as I said in part one, it wasn't associated with rain. Because if it was, oh, look at that! Oh, wow!
Wow.
See.
Okay, that's pretty spectacular.
That's the typical Orion blowout that you expect to see. Okay, that's the Orion that we know. Okay, if you actually look at this now, okay, take a look down here, and you look at this area of the nebula. It looks like you're looking at some kind of liquid. Okay, look at how sharply defined this area is. This is actually an area that's actually like a shock front of moving material, and the dynamics of material that move within a nebula are very, very complex actually. Now keep in mind, the trapezium is making much of the nebula glow, and the trapezium, of course, is deep within this white overexposed area now. But then you've got the bay, which is that dark area that you see there. That's dark nebula that's superimposed over the bright nebula behind it. Okay, this is gorgeous. So with that in mind, I want to do one more thing. I could just do one more, then just one more, then one more, then just one more. I'll never get in. And then here's another one. Look at this. Look down here. Okay, right down here. Let me just get my thumb out again. Okay, because my thumb was freezing. Check out how sharply defined this is down here. Look at that. That's real. That is not artificial. We're not generating this. That's just what it looks like. All right. That is stunning. Stunning. Absolutely stunning. You know? So, that said, I'm gonna want to do this again, by the way. Just a second here. I'm going to bring us up, or bring us down a little. Oops, it's a little too much. Wait, where are you going? Go the other way. Okay, let's try that. We're going to do the same thing one more time. So, I'm trying to just get a portrait of the nebula that will be something that you guys can hang with and enjoy. There's so much to it. There's so much depth. And when you overexpose it like this, you lose much of the stuff in the center. But I have a way of processing it so that you can still keep the stuff in the center. You know, and this nebula is like 1,400 light years away, which makes it one of the closest stellar nurseries. So it's actually why it's so big in our sky and why you can actually see it with your eye. You know, when you look in the sky. Obviously, it's Orion's sword below the belt of 3 stars. And to the upper left of it is Alnitak, and then the middle star is Alnilam, and then Mintaka on the right. And Alnitak is just below Alnitak is the Horsehead Nebula that we saw, and just above Alnitak on the left is that's beautiful. Just above Alnitak is the Flame Nebula. But who needs all that when you got this, right? Look at this. It's going to be here all winter long for us guys. Wow. Okay. Well. And pretty much this that you see here is kind of what it looks like, with your eye. But you know what? I want to show you a little bit different.
We wouldn't see that color with our eye, though.
No, you wouldn't. That's a good call. I mean, I was going to say that in a bit, but you wouldn't actually see this at all with your eye like that, right? But I want to point out something that you would see. All right, and to do that, I have to change the mode on the camera. Let's do this and see if I can get away with it. Okay. Not that one. Not that one. This one. Okay. All right. This is a a live mode where we can actually adjust the ISO settings and see exactly what you would see. Okay, this is kind of how you know, with the earliest telescopes you might have had, you might see this, and then as you get another telescope that has a little bit more aperture, that is opening in the end, you might see that. But then get even bigger, and you might actually get to see those wings around the outside there like that. This is right here. This is what you would see in this telescope when you look at it through an eyepiece. That's how the Orion Nebula would look. All right. So that little nebula up above the Orion Nebula, okay, that right there would probably look just about like that, a little bit fuzzy. And then when you get bigger instruments, you know, then it can look even more pronounced, and so forth.
Yeah, it looks fuzzy.
Well, yeah, but I'm just showing you the amount of light you're gathering.
Yeah.
So then, now to go back to where we were. I'll do that. That's what we're in manual mode. Okay, right. So that's where we are. So that's how it would look when I just showed you. So now, one more time before I do anything, I want to go back up and just. Now the flame is even higher. I want to check out the flame one more time. And yes, I know the horse head, but all right. So here we go. And by now you know Alnatak on the lower right there. So let's do 30 seconds at 25,600 here and see what we get. If I can handle it before I freeze. Oh, there's so much to see here. So much to see in the sky, and it's like I just don't have enough warmth to show it all to you, for crying out loud. All right, what are we looking at here? So just above her, to the left of Orion, is the constellation Gemini. And one notable cluster in Gemini is M35, which is a really beautiful cluster. We won't be able to see it tonight because I won't last. Oh yeah. Now, what's nice about this shot is you can actually see. I'm just going to bring that down a little bit. You can actually see in this shot, and I'll go back to it just for a sec. You can see the, come on, finger. You can see the beauty of this flame nebula and the bright nature of Alnatak. And I just think that's really pretty. Just gorgeous. Oh yeah. Yeah, I'll just do one more here. You know, we could actually explore Orion all night long and never come back to the same thing twice. There's so much up in Orion, and I'm going to try and do that. But I've really got to get warm again. I'm just like,
because I know you love it so much. I know you want to do this all night, but
it's crippling cold. I mean, it's just crippling
it's not
cold.
Worth losing fingers and toes over. It really isn't.
Well, yeah, it is. It's just crippling cold. You know, and I don't like the pain. Otherwise, I don't mind fingers here or a little toe there. I mean, I don't care.
Well, how are you going to take the pictures?
Yeah, sure. You know, you make do. You'll figure it out. voice activated. Hey Siri, take a photo. Sure, I will do that now. Click A. Oh, that's so funny because on my iPad, Siri actually activated when I was joking around saying, "Hey Siri." That's very funny. Okay, let's go back and see what this came out as. Yeah.
Oh, I heard that.
Yeah, that's funny. That was Siri. Wow. Yeah, you see all the dark and convoluted areas in this in the Flame Nebula. That's actually more dark nebulae that's between you and the bright nebula behind it. Very, very common, in, to have that type of thing. But look at that; it's just beautiful. Anyway, I'm going to. We're going to end up calling it a night here because I've really kind of overstayed my welcome in the observatory, and it's really cold in here.
I can just tell on the way back to the house, all your tears are going to be turning to little icicles.
Oh yeah, I don't want to leave.
You have to go in and you can't watch this beautiful sky. Look how bright the stars.
I know. That's Al-Natak is gorgeous. Yeah, and it's so cold actually in here that my iPhone just rebooted.
Wow,
yeah,
dude. Yeah, that's not cool.
It rebooted. I mean,
well, it's way too cool, I should say.
Yeah, it's way too cold for this.
But hey, a two-part stream, that's pretty cool itself, so...
Well, two-part, but, how much was two-part? It was sort of not really very long here. I feel bad about that.
I don't know. I don't know how long the first one lasted. I thought it was about 2 hours. I think this one's probably been about an hour and a half, 2 hours.
Really?
I don't know. Hold on.
Oh, that's crazy. I can't believe that. Maybe it is. All right.
Oh, maybe not.
This, I think we've been in this probably maybe about 45 minutes. That's my guess. But then again...
Well, it looks like at least an hour and 20.
Really?
Looks like.
Oh, man. I have such
Maybe
a
someone has better...
Time flies when you're having fun, even when you're cold.
Yeah.
I'm going to do something here. I'm going to do...
Well, at least it makes freezing death worth it. If it wasn't fun,
oh,
it would be even more painful to be doing, right?
What a fascinating commentary. Okay, hold on. I'm going to do 30 seconds of the Orion Nebula at a 16,000 ISO. So it's going to actually be less sensitivity, but you'll notice that you're going to see mostly the same detail, but the bright center is going to be a little more subdued. It won't be as bright, and you'll see some more of the convoluted, darker areas in the central part. Because I dropped it 2 stops in there, so that means that instead of 25,600, and it wasn't 20,000, it was 16,000. So it's going to be, it'll be reasonable. I mean, this is one of the nearest, stellar nurseries to us, like I said. So it's quite large in the sky, Wow. So we'll see. A couple seconds.
Well, maybe. Ooh.
Yeah, that's pretty. That's pretty.
Maybe when you go in and warm up.
I can come back out again.
You're going to bed, you could
come back out again.
Well.
Alright, I'm going to do 30 seconds at 8,000 now. Just to round it out, because 8,000 from 16,000 is literally several stops lower. And I want to make sure that we can still see all the outer detail and all the inner detail. The nice thing about the Orion Nebula is that it's bright enough so that you don't actually have to take a stacked set of images of it to really get a nice picture. When I stack images, it's usually for galaxies, so you can make the signal, that is the galaxy, star clouds, look brighter against the background of the space. Okay, and that adding the signal like that is how you build up an image like that. You stack them together. And you do it digitally so that all the stars are aligned and the galaxy clouds are all aligned with each other. But when you do it with the thing like this, it's so bright, you almost don't need to. It's better to just take 1 or 2 exposures at lower values, and you can always combine these and blend these together, in a way that is tasteful. All right. So, can you tell that I'm just like, I'm part of me is like, I gotta go in, I gotta go in, I gotta go in. But wait, what's one more? Just one more. So now I'm at 6400 ISO sensitivity. We came down now from 25,600, remember, and now we're only at 6400. So if you look at the difference, and I'll just quickly go through them before I close up. I don't want to close up. I just want to keep going. But you know what? I'll look at it this way. Orion's going to be this high in the sky at sunset in just a couple months. So we'll come back to Orion multiple times, I'm sure. So now we're at 6400. So you're going to notice that you still see a lot of the same detail. And it really is, it has to do with the fact that the objects that we're looking at are so bright that it doesn't require a huge, long time exposure to capture them. And you can only get so much out of a time exposure. You still see them, and you still see them in detail. So it's best to just kind of hunt for the best ISO sensitivity, which gives you the best blend, as you can see there, the best blend of the darkness of the nebula with the range of colors that you see. And you can see here, that's actually a beautiful photo, just like that. Nothing else needed. I could actually go even better. I'm going to try and just move it down a little more. See, listen to me. Just one more, just one more.
Even worse, it's not even just one more, it's let me try to do myself.
Yeah, I know, that's what I'm trying to do.
And that's going to be endless. Oh, if I just angled it better, or if I took a long exposure.
I have all winter to do that, don't I? Now I'm going to go to 4000 ISO in 30 seconds, and let's see what we get. And then I'm going to run through them all as a last thing and show it to you. And then I'll close up. This is the last photo, I promise.
Don't promise.
If I promise, it's done. I can't go back on it.
Promises are made to be broken.
Yeah, not this one. I get it. I recognize my limit. It's like someone who drinks too much at the bar. They know how much they should drink, and they try to stick to that, right? At least they should. Too many people don't, but you should.
Which kind of blows your theory out of the water.
Yeah. Okay. So never mind. That's kind of a bad analogy.
Yeah.
It's like, no, that doesn't work either because they.
Well, I mean, you have an addiction to these space objects, so.
Ooh, that's an interesting way to put it.
Well, no, because this way, okay, well, I want to take it from different exposures and different angles and blah, blah, blah.
There it is.
So.
That's it.
It keeps giving you reasons to, it's like a series of last photo.
Yeah. Well, here it is. This is it. This is the last photo right there. Look at that. That's it. The Orion Nebula, the quintessential Orion Nebula. And now I can get inside and warm up and then go to bed and my feet will be warm by morning.
Aww, Bert.
Yeah, I know. It's cold.
Well, I was going to say, I thought you had a heater going in your office.
Oh, I
you
do.
just stand in front of that for a few minutes and
I'm going
consider
to.
joining us over at Bill's. Bill and my Skywatcher.
I might do that, actually. I might. Yeah. In fact, I may very well do that.
Well, it should be about midnight your time, and that's when...
It's 12:05.
Well, I heard the peak was between midnight and 6. I know there's a bit before and after, but hopefully we can all keep our fingers crossed.
Yeah. That'd be pretty cool.
Little blasts or whatever we're going to say.
Yep. So, folks, I want to thank you for attending the part 2 of SkyTour Livestream with me and Amanda tonight. I really appreciate you being here. Please let me know your thoughts. I've actually got a huge number of clouds coming, so this is actually a perfect time to stop, because by the time I close up the observatory, Orion will be covered with clouds. Whew. And that means that we kind of lucked out tonight, and I'm really happy about that.
It was a great stream.
It was wonderful. I'm very, very pleased with.
And we're not going to make anyone wait nearly as long as we did last time for the next stream, right?
Well, that's not up to me. It's up to the clouds. It wasn't me. It was the clouds. We had too much
and the dome
weather.
falling apart.
Well, actually, the dome fell apart during cloudy weather. Not fell apart. It was ripped apart. And so that said, I didn't actually make it, through a stream where I lost a stream because of it. It wasn't clear enough. So, I'm okay right now. But the dome manufacturer, Next Dome up in Canada, ta-da! They are sending me free of charge brand new shutter assembly and a brand new dome panel that was ripped to pieces and damaged. And I glued this stuff together with a product called JB Weld, okay, which is like steel once it cures. But I had to do it in 15-degree weather, and it still cured. All right, and I had to drill a hole and put a bolt and put a wheel on it, because the wheel was torn right out of the plastic top of the dome. And I was able to do that with JB Weld in the 15-degree weather. And let me tell you, it feels just like that now. But anyway, hey folks, thank you for joining me tonight.
Dome would be warmer.
Yeah, well, I wish domes could be warm, but they can't. And that's okay. I mean, they shield you from wind, and that's their value. That's the value. But I do want to thank you all for attending. Thank you for attending the SkyTour Livestream. It was too cold for my phone. It actually rebooted and then it shut itself off. So that's another problem to figure out. But I will see you on the next SkyTour Livestream, and hopefully Amanda will join us too, because she is the other half of the SkyTour Livestream. So thank you guys, and I will talk to you later, perhaps over in Bill, New York Skywatcher stream.
Have a great weekend, all. Hopefully you can enjoy the late nights tonight.
Exactly.
Viewing.
But I don't know if I should I hum the tune, the end tune? Da 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 da. I don't know. I gotta get a life. Okay. Good night, folks.
You gotta get warm. Good night.
I gotta get warm. Yeah, I'm getting punchy. I'll see you guys later. Wonderful to see you here. I leave you with the Orion Nebula. Good night.